All right, today we're going to be talking about right triangle trig. So we're going to find the values of the trigonometric functions, and then we're also going to go ahead and use them to go ahead and find the values on right-sided triangles. So use trigonometric functions to find sides and angle measures. Well, I'm sure you are aware of the three trigonometric functions on the left side here, the sine, the cosine, and the tangent. The sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. What you may not have been told is that there are three more. There's the cosecant, the secant, and the cotangent. Now, each of these goes ahead and works in conjunction with the one that is opposite it. They are actually reciprocals of each other. So the sine is opposite over hypotenuse, so the cosecant is hypotenuse over opposite. And there are times to go ahead and use these different ones, but you need to understand that these are possibilities of ones that we go ahead and have. Most of them can be converted back into sine, cosine, and tangent, but just understand that cosecant, secant, and cotangent match up with the appropriate trig function across from it. So see how the sine here is 4/5, the cosecant then is 5/4. Cosine is 3/5, secant is 5/3. Tangent is 4/3, cotangent would be 3/4. So how do we do opposite, adjacent, and hypotenuse again? Well, here's our angle. We always start with the hypotenuse. Hypotenuse is always the longest side. It is also the side that is not next to the right angle. So it's this side here. Then you have two other angles, two other sides. One is next to the angle, that is considered adjacent. And then the other one, of course, would be on the opposite side of the triangle and considered opposite. So here we have a triangle, 24, 32, and 40. And we want to find the trig functions to angle G. So here's G. So as I said, we start with the hypotenuse. This is 40 is the hypotenuse. And then out of 32 and 24, which one's adjacent to G? Well, that's 32, so that's adjacent. And 24 then would be opposite. So to find our different values, we're going to go ahead and have to have those. So we have opposite is 24, the adjacent is 32, and the hypotenuse is 40. So let's go ahead and start with our sine. Our sine is opposite over hypotenuse, or 24 over 40, which reduces to 3/5. Cosine, adjacent over hypotenuse, so 32 over 40, or 4/5. Tangent then is opposite over adjacent, 24 over 32, or reducing to 3/4. You do, of course, always need to reduce. So to match up with the tangent here, we have the cotangent, so we just flip it around. This was 3/4, so this is 4/3. You really don't even need to do all of this if you've already done the tangent, because it is just the reciprocal. Cosecant again goes with sine here, so that was 3/5, so that's 5/3. And then we have the secant, which is opposite of 4/5, so 5/4. And those, of course, then are all our answers in a much better grid with matching things up. All right, so we can go ahead and use this information to go ahead and find sides of a triangle. If they go ahead and they say that the tangent of A is 5/3, well, tangent, remember, is opposite over adjacent. So opposite is 5, so the adjacent is 3. So then the hypotenuse is this value over here. We don't know what that is. In order to find the hypotenuse, we can use the Pythagorean theorem. A squared plus b squared equals c squared. So using the Pythagorean theorem, a squared plus b squared equals c squared, we have the a and b, 3 squared plus 5 squared, which is 34. Take the square root of both sides, and we have the square root of 34. Now we do need to reduce that. If there's a perfect square that goes into 34, which there isn't, it's just 2 times 17. So we are okay here. Now we need to find the cosecant. Cosecant is hypotenuse over opposite. So hypotenuse over opposite, and we're just going to go ahead. Now we know what the hypotenuse is. It's 34, and the opposite is 5. So we just write it as square root of 34 over 5. And that's my answer. And I can do it with any of them. They just asked for the cosecant this time. So here we have the sine being 2/3, so the opposite is 2, the hypotenuse is 3. So we need to find the other value, the adjacent, to find the cosine. So the adjacent is going to be this x squared. So it's 2 squared plus x squared equals 3 squared. The hypotenuse, again, remember, is always by itself. 4 plus x squared equals 9. X squared equals 5. X equals the square root of 5. So that's the adjacent. Cosine is adjacent over hypotenuse. So square root of 5 over 3. By just finding the other side, we can go ahead and write down any of the sine, cosine, tangents, cosecant, secant, or cotangent. All right, in order to go ahead and use our calculators, you want to make sure that you hit the mode button. The mode button is right next to the second button at the very top. And you want to go ahead and change it from radians to degrees. That should be the third line. It should be in default in radians. If it's already in degrees, obviously just leave it in degrees. So we need to go ahead and change it from radians to degrees. We'll actually talk about what a radian is in a lesson coming up here in this chapter. But as of right now, let's just deal with degrees. So to test this, to make sure that we have the right after you just quit out, you want to type in the sine of 30. The sine button is above the 7. It's 2 above the 7, and it says SIN, and then cosine and tangent are right next to it. So sine of 30, you should be able to type in sine and then type in 30 and hit enter. And you should get 0.5, not negative 0.988. If you get negative 0.988, you're still in radians, and you need a change. All right. So once you've gotten that, let's go ahead and move on to this next part. So we want to be able to find the missing length. So they give us an angle and a side. So the angle is 60 degrees, and the side, this one, the hypotenuse, is 12. Well, we need to understand where x is. X is opposite. So we have opposite and hypotenuse, so I have to go back to my trig functions and which one has opposite and hypotenuse. Well, opposite and hypotenuse comes from the sine. So we're going to use the sine function, opposite over hypotenuse. So the sine of 60 equals x over 12 because 12 is the hypotenuse. We could put this over 1 here and just cross multiply. So 12 times the sine of 60 equals 1 times x, or just x. This then we can type into our calculator. You should get 10.4. And that's our answer. 6 root 3, or about 10 root 4. We'll explain how to get 6 root 3 later on in the chapter also. All right, to calculate the height of the building, Joel walks 200 feet from the base of the building and uses an inclinometer, which just is basically a fancy protractor, to measure the angle from his eye to the top of the building. Joe's eye was level at 6 feet. What is the distance from the top of the building to Joe's eye? So we want this distance here. So they say that he's level here, so 200 feet. And this is 76 degrees. That's what they said was the degrees that he got. So this is adjacent, and this is hypotenuse. So adjacent and hypotenuse is the cosine. So we're dealing with the cosine of 76. So cosine of 76 equals 200 over d. Again, I put this over 1 so I can cross multiply. And then we'll divide by the cosine of 76. So d equals 200 divided by the cosine of 76. 826.7 feet. So about 827 feet, roughly, to the top of the building. Don't know why he needs to know that, but that's about how far it is. All right, height of a tree. I think you did this last year with Miss O'Day. Walk 50 feet from the base and use your protractor to measure the angle. It was 62 degrees, so the angle is 62. And the height would be opposite. The adjacent would be the 50. If you need to draw a little diagram, feel free to do so if that helps. So opposite and adjacent is tangent, so tangent of 62 equals opposite over adjacent, so x over 50. Cross multiply, 50 tangent 62 equals x, so x equals 94. Now he is 6 feet tall, so you should add 6 to this, and it should be 100 feet. They did not. Not sure why they did not, but most assuredly the answer would be 100 feet. Wrong. With our trig functions, we also have inverse trig functions. So if we have the sine, we have the inverse sine. Remember, we always need to be able to undo the other thing that we've done. So if we're doing the sine of something, we should be able to do the inverse sine. And it's marked here with this -1 sign here. The other way that you can do it is called an arc sine. They put arc in front of sine instead of the -1. Both are acceptable. Both mean the same thing. So what does that do? It basically finds the angle for you. So before, when we were putting in our calculator, we put sine of 30 and it gave us an answer. Now we take the answer and it goes back and gives us the angle. And we can do that with sine, cosine, and tangent. We can do that in our calculator, and the way that we do that is hit second sine, and it should come up sine -1, or second cosine, second tangent. All right, so we are missing, or we want to find out what A is over here. And we're going to round to the nearest tenth. So we need to go ahead, and we have our 3 given sides, and we need to go ahead and pick one. Now we could do the sine, which would be 9/17, or the cosine, or the tangent. It really doesn't matter which one you want to do. 9 and 17 seem a lot better than the 14.4, so that's why I would go with sine. But you have sine of A equals 9/17. And so what you do with your calculator basically is you hit second sine, and then you do 9 divided by 17, and it should give you an answer. And about 32. I got 31.997. So they want you to round, so 32 degrees. So what about B on the other side? Now we can do the same 9 and 17, but now because we've gone to the other angle, this would actually be adjacent. Notice how adjacent and opposite switch. Hypotenuse is still the same. So if adjacent and opposite switch, 9/17, that of course gives us a different value here. And we're going to get 58. I got 58.03, but they said round to the nearest tenth. So what would the measure of A be? We can do 3 divided by 6. When you do 3 divided by 6, you should get 30 degrees. And here, then, the cosine of 3 divided by 6 would be 60 degrees. All right, angles of elevation and depression. They end up being always from the, if it's below the horizontal line, that's depression. If it's above, then it's an elevation. But they end up being basically the same thing in terms of what you're trying to find. So here we have an angle of depression of 60 degrees, and it's dropping. We have this roller coaster dropping and falling down. They want to know how far across we go if we drop 195 feet. So 195 feet is in the opposite spot. X would be in the adjacent spot, so we're doing a tangent. Now this is a normal tangent, not a arc tangent or inverse tangent, because we know the angle. If we were trying to find the angle, that's when we would do the inverse. So this is just normal tangent. So it's tangent of 60 equals 195 over x. Again, we're going to have to cross multiply. So x times tangent of 60 equals 195. So x equals, I'm not quite sure why 195 became 36. I don't know why that happened. This is the correct answer. If you have the 195 divided by the tangent of 60, you'll get this. That's the correct answer. That is a mistake somehow, somewhere. So the horizontal distance on that hill is 112.6 feet for the vertical drop of 195. Angelina is flying a kite. Her string length is 60 feet. If the angle of elevation is 55 degrees, how high is actually the kite in the air? So if you're doing the kite, the hypotenuse is 60 with an angle of 55. And we want to know the opposite value. If you're standing here, the kite's up here. We want to know how high it is. So that's opposite. Opposite and hypotenuse means sine. So sine 55 equals x over 60. Cross multiply again, x equals 60 sine 55, and we get 49.149, or just 49 feet. And that's what I have for you today.